to record for anybody that doesn't show. Yeah, so since the other works, I guess we can skip. If you've ever seen BattleBots, very similar idea. A ring is made, right? And you put your two robots in the ring, you and your opponent, and try to fight it out. There we go. We'll kind of see. Yeah, the robots are remote controlled, right? So there's nothing to do with any what's called autonomous activity, I guess. It's not autonomous, right? So we will have a driver. We can let's try it out once we get to that point, if you'd like to. Yeah, and a lot of carnage, which is I think the best part. Definitely why I joined it. Watched a little bit of BattleBots, so I wanted to kind of do this, and yeah, it still looks exciting. Okay, I think we can move forward. Try it. Can you guys hear me?
Yep.
Okay, perfect. Just making sure that I'm not talking to myself. So, sometimes that does happen. Yeah, go ahead. Let's move forward then. Or who's that trolling this? Go ahead, right? Perfect. So, kind of like what we said last time, right? I think we mentioned this before, but what is combat? It's type of robotics competition where two more remotely controlled robots battle each other with the goal of disabling or destroying each other. Again, disabling means that you just can't move forward. Your weapon stopped working. If it's a spinning one, it doesn't spin anymore. If it's the lifter, like we saw in the video, it doesn't lift anymore. So that would count as disabling. How would you know a little bit more than that? Is it a tournament stuff? Or is it point stuff? I haven't been, so I'm not 100% sure. I'm not gonna lie. But yeah, I think you definitely fight two rounds. Well, that's the idea, right? If you bring a couple of spare parts, whatever you can swap on the fly, right? But you have to kind of hope that you survive through. So that is one of the challenges. You don't want one hit to disable everything that you have, and if it does, you hope that you designed it well enough that you can open it up and change whatever needs to be changed. Which we'll actually talk about designing process a little bit later. There's some key points in there. So here again, you kind of lay out the common weight classes, right? Ant weight, heavy, hobby weight, featherweight, lightweight, heavyweight. We're going to be in the featherweight category, or at least this competition is. We used to have a heavyweight, but that competition was canceled. So we're sticking to just the featherweight now, 30 pounds. One more time, that's a very difficult design challenge to accomplish. Right? There's a lot of research that goes into materials and making sure that your design, you account for the amount of metals that you're going to use. You have to count the batteries are going to weigh a lot. Right? We want it to not run out of battery during one round. Yep. So next slide. What can we expect? Again, just like I mentioned last time, everybody's going to get design, right? So that's, I think, a really cool part of this. Learning how to use design software is, I think, pretty important. It allows you to do a lot in the future right? Like if you're working at any job or even if you're researching, being able to quickly 3D design something, and then now that printers are very accessible, 3D printers, makes prototyping a lot easier. So designing is a big component. I think one of the most beneficial parts of actually joining the team. Then we get to manufacturing, right? This is the part where we're going to split up into mechanical and electrical, and we need to work on actually building it. So some people will get to go and build the body, like the chassis and the weapon, and construct it all together. That's usually people that have a machine shop certificate or license, which you can get at a course in George Brown. George Brown, if you don't know, is really close to U of T. They have a machining course. I think it's 2 weekends long, just a Saturday, a few hours each Saturday. So 2 Saturdays, a couple hours. I haven't done it, so if they open it up, you can join me. I'll do it as well. And yeah, so that's for machining, and then electrical. There's the electrical systems on the inside. You have to make sure that everything is robust enough so that it doesn't get destroyed easily. And yeah, we're dealing with high power, so wires are usually heavy. It's nice. Soldering, if you want to learn how to solder, it's good use of that as well. And then there is the new My Hall building that's opened up, so that can be used for very small manufacturing. But if you've ever been in it, you'll notice that you can't do much there, which is kind of disappointing. And then we go to testing and training. Again, this is the point where you hope that your robot works, and you hope that you can assign a driver, and we can have many people try to test and drive it. But I think in the previous year, specifically with Annie, you see in the picture, I don't think there was much time between somebody being able to try it out and actually going to the competition. So, it gets very tight at the end. And then we get to the competition. There you go. This one was in Illinois. Yeah, we're hoping to have it again. If not, we'll try to find something else. But yeah, I think that's the exciting part, right? Getting to see what you've done, what you've achieved, hopefully work. Next slide. So again, manufacturing, right? We have design. Nice, get this on that. Designing. You have to design the chassis, you have to design the internals, it's a big one. Material picking, this was my favorite part. If you're into materials or you think you are, doing this research is pretty fun. Right? You want to find the lightest material, I guess the biggest bang for your buck as well. Lightest material, highest strength, or toughness, depending on what you're looking for. And transmission, you might think like, oh, it's pretty simple, right? You just want the weapon to spin and the motors and the wheels to spin, but how are you going to design everything so that you can get it to spin? So are you going to use a pulley system? Are you going to use a pulley and belt, a pulley and chain? We had another design for Beyblade, which I hope to show you, but I wasn't able to get my ECF working, so I'll show you another week. The entire design, and that the motor design and the way that we got it to spin now, or not got it to, the way that we want it to spin is very challenging as well. So it's a fun design challenge. And then you pick your motors and your electronics, right? Pick the right part for the design. So again, motors, you want them, pretty strong, brushless or brushed, usually brushless. Yeah, and then we're hopefully going to use SolidWorks. I think we're going to get a sponsorship from them this year, and so everybody will be able to download their software. I know I prefer SolidWorks over Fusion 360, and I think Bobby does too, from what I understand. So yeah, this is going to be exciting. Designing. Next slide. Now manufacturing. Like I said before, there's going to be the machining, assembly of everything, circuitry, soldering, welding. Welding we don't usually do because we don't have a place to weld. Soldering and circuitry and machining, we definitely do. And again, this is the part where we realize that you've messed up on weight. So as you can see in the right picture, you kind of have to be a lot of, I guess, what would you call it, golf ball design. You want to you want to dimple out as much weight as possible because these guys were overweight when we did M. So yeah, and even if you design for something, you might have messed up some calculation, not realized one thing weighed a little bit more than something else than what you thought, or maybe you're reusing a part. Right? You did research on this one specific motor, and then you were like, oh, we have some motors in the back in the garage, so you use that and kind of screw yourself over in terms of weight. Yeah, manufacturing is another really fun part of it. I think we didn't get very far last time, so I'm hoping that we actually get to do it this year, especially since we're starting to move on campus. This will be a very fun part, and yeah, we don't get to do this in classes very often, right? So in engineering classes, we do a lot of theory, maybe design, but manufacturing can be an interesting item. Next slide. And then we go to test, train, and competing. Right, so now we're testing our circuitry, making sure that we wired everything correctly. We're doing improvements. Like maybe you noticed, something that you added in was wrong, or the weapon maybe it's not as good as you thought. It's imbalanced, right? Here you kind of tweak some stuff. Train the driver. Again, we hope that we have time for that. Where somebody gets to learn how to drive it, so we can compete, and then we go to compete. Next slide, and I'll pass this on to Bobby.
All right. So here you can see our timeline for the year. So it seems, I guess, not too imposing at first, but definitely, getting to the end there, it usually becomes quite a time crunch. So you can see in October, it's very sort of beginning sort of stages of the design. So part picking and rough design. So pretty much what this means is, there's a lot of different sort of types of robots, and we'll go over that after the kickoff slides. But so there's vertical spinners, horizontal spinners, drums, all sorts of different weapons. And so we first need to just roughly choose, what category of weapon do we want to actually fall within. And then from there, figure out sort of a rough sketched out design so that we can pick which parts we're probably going to use. And from there, start to sort of actually get a solid design figured out. So November is when we would be aiming to have the CAD modeling happen and wrap that up by the end of November. So we have our design finalized at that point. And then in December, we're ordering parts, a lot of manufacturing. So generally, December, we will try to do all of the manufacturing. It never happens. As you can see, it continues in January and February, but it's always good to aim to do as much as you can in December, just because it always seems like less than it actually is. So January inevitably usually ends up being even more manufacturing, along with February, but I guess the goal here will be trying to finish it up by January, and then we can do a lot of testing in February. And then finally with March, it's final testing, driver training, which is an important step to have, just because otherwise, if you haven't practiced a lot with driving the robot, it's not going to necessarily be giving you the best performance at the competition. And then finally, competition. So next slide, please. So the competition that in the past we've gone to is called RoboBrawl. It's in the University of Illinois, and we fly out to it. So at the moment, the date is still to be announced. They haven't really confirmed any of the details yet. So there's a chance that RoboBrawl may not be happening. If that does happen, then we'll look into tons of different alternatives for where to go. But it's a pretty fun event. It's, a whole bunch of people just like us getting together and fighting their robots potentially to the death. So let's go to the next slide. You can see this is the last competition that we went to. So this robot was named Annie, short for Annihilator. And so before there, the shot, it's a little far away, but it's a nice, clean, functional robot. And after, you can see, there's chunks of aluminum that have been torn out, pieces missing. It definitely gets roughed up. So I saw there was a question earlier, I think, in the chat about like, how do you have it survive and make sure it still works in future rounds? And the answer is you don't necessarily. So the goal, of course, is to make it throughout the entire competition and, win all of your rounds, win the competition, but you're definitely going to get damaged throughout the competition. So in this case, Annie was quite damaged, but still functional. So the goal is pretty much design it and have enough spare parts that whatever damage does inevitably happen, you can then deal with it and not just be disabled and have to drop out of the competition. So we have three designs or three robots that are going to be happening this year. So next slide. But just going over, I guess, sort of the plan is that two of them are previous designs, which we will be finishing off. Since the design work is done, we have some of the parts manufactured and most of the parts ordered, and then we'll be designing one new one entirely from scratch. So we'll just go over the existing designs. So Ben will cover Beyblade now.
Yeah, so this was, I guess, the one that I worked on mostly. It's the Beyblade one. So it's hard to tell by this picture. And again, I'm sorry, I wanted to get a. Yes, this is the robot from 2 years ago that we wanted to, aggressively, that we wanted to get it to work. We wanted to build. So it's hard to tell from this picture. I wasn't able to get any, design software working. So sorry, an ECF won't let me log in. Just kind of depressing. But if you can kind of imagine, the inside of this robot is stationary. If you guys can see where the wheels are and the disc on top on the left side, right? And the outside, the entire rings, all the rings and those two blocks, one on the right, one on the left, that part spins. So that was the design where the entire outside spins, kind of like a Beyblade. And the inside stays still. And like I was saying before, right? The challenge with this, getting the outside to spin, is how would you think about doing this, right? It's a little bit difficult because you want the internals to stay still. So what we did, or what we want to do, is we have a wheel that glides along the outside, the exterior, and the wheel spins. Right? I guess if you think of a ping pong shooter, it's like how you shoot a ball, right? So the outside spins, and this wheel is pushed in contact with kind of a spring, because if there's we're amateur designers, right? At least I definitely am, and amateur manufacturing. So you're not going to get your tolerances good, and as well, once you get damaged, your tolerances are definitely not going to be perfect. So you want to make sure that you're always in contact with the outside. And that was kind of the biggest challenge with this, as well. Fitting electronic parts into a circular interior is also pretty difficult. So you can kind of see the jumbled up mess. There's a gearbox connected to a motor, and it's way off to the right and not in line with the motor. So that was another challenge, right? Making sure everything fits. There's a lot of big pieces inside that you have to account for. So that was this one. Next slide, and pass it back to Bobby to explain.
So this is the other robot that we were assembling before COVID hit. So it's currently in the assembly process. We still have some machining to do, some parts to get and stuff, but we're hoping to finish this one as well. So it's a more, I guess, simple traditional design. It's basically a horizontal spinner. So you can see it looks kind of like a disk drive, but the disk itself there has a big tooth cut into it. And so essentially what that is 1/3 of the 30-pound robot weight is just a giant tool steel spinner. And so that gets spun up to, 20,000 RPM. And the idea is that if it connects with any other robot, it's putting in, many, many, many kilojoules of energy. So hopefully doing a fair amount of damage. So you can see a lot of the challenge with designing these robots is also actually making them within the weight limit, but still being somewhat structural. So you can see all of the holes that are cut out of all of the supports there and how it's kind of a skeleton-like design. And that's just necessary to be able to come in under the weight limit, given what needs to be included in the robot. So this one we're hoping to finish as well this year. And then I will pass it over to Shahid for the new robot design potentially.
Yeah. So this time we're having 3 robots. So as you saw the last 2 designs, a considerable amount of work has been done in designing. So in the new robot that we make, we'll start from absolute scratch. And we have to like discuss what kind of weapon we want, what approach we want. There's certain rules. So I think for Robo Brawl, I remember reading we couldn't have flame, and we couldn't have detachable parts. Oh yeah, I see someone. Yeah, we can't have flamethrowers, unfortunately for Robo Brawl. But yeah, so then once we start working on the new design, we'll see the pros and cons of each design. Here, the pictures on this slide are from our battle bots. So you could see the one on the top right is like 2 of them. It's like a drone plus a sledgehammer. I don't think so that's allowed. So you'll have to make sure we choose an acceptable weapon. Like together as a team, we'll see what is something that we can do and what is something that's good enough. So this hopefully we'll pick a design before, like in the next week or 2 maximum, and then we'll start designing on it. And yeah, and then you guys saw the timeline of hopefully start manufacturing soon. But yeah, so the 3rd robot design, we're going to start from absolute scratch. So hopefully that'll be a good experience for everyone. And here is why you should join, because this is a very close-knit team. So we are working together. And in Utra Comeback, what happens is we have a 1-year cycle. So usually we do not recycle like robot concepts. Last year was an exception because of COVID. We couldn't really manufacture and build the 2 designs that we have. So we usually start something from beginning to end. So that gives you a lot of experience of like everything, starting from CADing and then machining and then testing. So it's a great learning experience. Then there's a lot of technical experience because you'll be getting a lot of hands-on work with building, which is like mechanical plus electrical, because we need a remote control for the robots. So there'll be a lot of testing, troubleshooting, which is a good learning experience. Yeah, and then we'll build a cool robots. When we'll be practicing, we might like practice against the 2 or 3 designs that we have. So it's going to be fun practicing, seeing how much destruction they can cause in a safe environment, obviously. And then, as you all know, robots are going to take over the world, so it's might as well. It's good to, be on their side. And then we obviously need a driver. Hopefully, we finish it early enough that we can, like, have someone practice with the robot and, get good with it. So then, during the competition, they can. I feel like when you practice more, the way you move the robot could also, increase your chances. So that's like a very necessary step. So we need a driver as well, who's going to, destroy other robots. And if you haven't, please fill out the form. The link is here. The QR code is here. If you have any questions, you can direct them to lightcombat@utra.ca. Our meeting times haven't been decided yet. We'll discuss with everyone. Hopefully, I think weekends is a good time to have meetings, or whenever during the day, during the week. We all can decide that together when we want to have our weekly meetings. And do not forget to fill out this form. And that's about it from our side. If you have any questions, let us know in the chat, or you could unmute yourself. I think you guys can unmute yourself. If you cannot, let me know in the chat. And yeah. Okay, yeah, form slide.
By the way, we are going to go for one more thing after this presentation. If you guys have any questions, continue for a second, and then no, there's no requirements for joining. Just yeah, if you want to join, you can join. Again, just use it as a good learning experience. So it's not like a rover soccer where it's actually really difficult, and so they usually have a interview or signing up, and they actually screen people. This is good to learn. So we find that any again, more questions, and then we'll continue on to our next part. Will you learn it during do you mean will you learn skills during the club or from your school? But during the club. Yeah, definitely. We will hope to teach, right? I can tell you that in any of my classes, I learned 0 CAD skills. Not that I'm great at CAD right now, but I was able to do the basics. So yeah, all from the club. It gives, I think, a very good add-on to what you actually learn in school, and it doesn't, like again, we're UFT, right? So everything's theoretical. This is a good time to learn how to actually do stuff. Hopefully, again, in order to achieve something, like a final project or product. So yeah. Any more questions? Again, you can unmute yourself as well. That's perfectly fine. Okay, I guess we can continue.
Yeah.
We go for it.
Oh, do you want to share your screen for the second part?
Sure, do that. Yes, okay.
There's one more question. Do you all have Discord? We have a Slack channel. We think that's where the primary discussion would be, but I feel like Slack notifications aren't that great. But yeah, we can like switch to another platform. Probably like Facebook Messenger is good as well. Yeah. But so far we don't have anything else apart from the Slack channel. Okay, perfect.
Let's see. Can you guys see my screen?
Yep.
Can't see anything from you guys anymore, so no longer able to see the chat if any questions come up. So yeah, I guess this part we're going to go over a little bit. Something called Robotics 101 for Dummies. It's a good introduction to combat robotics. There is a book as well. It's a very good book to skim through the parts that you actually need, right? I wouldn't recommend reading the entire thing. That's a long read. Yeah, I think we have the link to it somewhere in the drive. So if you want it, we can look at it. Yeah, so we're just going over very quick basics. To start, we have the structure of the robot and kind of the best design practices and what works well. So again, one big part that I think we hit on a lot over today and last time was that weight is one of the biggest design challenges of combat robotics, right? Especially when you're in the lower weight classes, 30 pounds. It's really easy to hit that and to hit it in bad places too, right? So here, you kind of notice what we're aiming for. Usually you want the weapon system to be 30%. Again, since it's a weapon, right? You want it to be heavy. You want it to do a lot of damage, right? It's like, what is it? Impact is force times, whatever that is. Yeah, so you want your weapon to weigh a lot so that you can do a lot of damage. Drive system. Again, this is big. You want it to be robust. So it's going to take up a lot of weight as well. Yeah, you want to be able to move your robot around. It's pretty heavy. You want it to move fast. So this is going to take up a lot of weight. The motors especially. Wheels, not so much. But yeah, there's a bunch of metal components in here that are taking up a lot of space, but you don't want to overshoot this very high. Next is armor, right? Just like how you want to dish out damage, you want to be able to take it. So it's going to be the next biggest part. Again, this is, you also want to not just focus on how much it weighs, but where all the, I guess, heavy parts or the most structurally sound parts are, right? Like we're looking at Annie here. You want the sides to be robust because that's probably where you're going to get hit. In 30-pound competition, I think there's less things going up and down. You're not moving a hammer around as much. So you're going to be hit a lot from the sides. So that needs to stay robust. And that's why you kind of saw the top was where some weight was lost. I remember the picture where they were taking out dimples from the robot, right? You want to make sure that you're also distributing it correct. So it's not just the fact that it's 25% of weight, but it's also where in that armor that you're going to be putting the weight. And finally, the electronics. This you can't really get around. You have to have electronics. Right? You want your thing to run. And I think if you guys know, or maybe you don't, the batteries weigh a lot. Like if you've ever actually looked at lithium-ion batteries, they're pretty hefty, right? They are energy dense, but they get pretty hefty. So for the amount of charge that you need for a fight, it's going to be a lot of weight. So that's something that we have to account for when designing. You can't kind of think, oh yeah, the electronics is going to be like 1 or 2 pounds. You got to realize that, yeah, this is going to be a little bit. So, all right. The common types of combat robots. So you've seen what we focused on a lot was horizontal spinners. I think the 2 robots that we're currently designing are kind of forms of horizontal spinners, right? The Samurai has a horizontal spinner that it's pushing out in front of it, and the Beyblade one, the entire robot is a horizontal spinner. Right? Other than that, if we want to move away from that, there's also wedge bots, vertical spinners, which was kind of what Annie was. Right? You had the drum, flipper bots, crushers, which are pretty hard to do, I think, for this weight class, and then thwack bots. You just kind of have something sticking out and you swing it around. yeah, again, you can think a little bit more about what we want to do for our design, but sort of the general types of robots. And of course, you could build on top of these, right? It doesn't have to look exactly the way this does, but these are the base. Now, chassis. For the chassis, you have to choose a good material with a good balance between strength, weight, and toughness. Right, so you can see aluminum, titanium, and stainless steel are all good choices, but of course, we also have to consider cost. So I would love to make a robot out of titanium. You know, that's like a dream, but I don't think we have the money for that. You know, and then stainless steel, you know, you think, dang, it's like a lot stronger than aluminum, right? But it also weighs a lot more than aluminum. And you're also not considering ductility, right? So let's say I use hardened steel. You know, like a hit can break part of the robot, whereas if it's aluminum, where it's more ductile or malleable, a hit will dent the robot, right? So you're kind of choosing it based on what you think is necessary. And again, you want a high strength weight ratio, just because, you know, designing for 30 pounds. So the better you can do here, the higher your chances are of surviving. The weapon. This, if you saw Annie, and I guess it was hard to tell in the CAD model for Beyblade, but the weapon itself, I think Annie's the best example. The drum was aluminum, but the part that was sticking out of it was a piece of tool steel, right? Very heavy, so very dense. Right? That little piece was pretty heavy, but it's very hard. And that's what you want all the impact to go through, right? You want it to be like a small point. It's very hard. So yeah, that's kind of what you're aiming for in your collision. Again, reduce the weapon contact, right? You want high impact. You don't want to spread it out over a large space, or else they'll have, you know, a higher chance to survive the impact, right? You want to cause the most amount of damage every time that you're actually able to hit your opponent. Again, same thing, high force. So you want it to spin fast normally using a spinning design. So you have to design around that as well. You know, your materials have to be robust. Your spinning system has to be robust, making sure that it can handle these speeds without destroying itself. Yeah, and then the types of way to spin. Again, this is specifically for spinners. Types of way to spin the weapon. You know, you can choose, like I said, a belt. You can choose slip. These types of belts where they allow for some slip, right? So you're not kind of destroying the belt system. Yeah, this all goes into the design process, which we spend the first, you know, what was it, October, November on. This is what we're focusing on, making sure that we choose the right part for the job. Now, mechanical, building everything together. There's a lot of ways to join materials, right? You can use screws, welding, zip ties, which are a favorite, shaft mounting, this guy, rivets, and hinges. It all depends on what you're trying to achieve. What you kind of take into account, let's say I have a screw hole on the border of my robot, you know, now the material around the screw hole the screw hole is very thin, right? So if something impacts, if I'm expecting high impact around the screw, then I can kind of expect that thin metal where I put the hole in is now going to be a very good point of failure, right? So that's something that we have to account for as well when you're choosing your mounting, right? So maybe that would be good for welding instead. Not that we weld often or much at all, but you know, this is type of stuff to consider, as well as the size of the screw, right? You know, you can choose a smaller screw, a thinner screw, which is probably going to shear really easily, or you can choose a thicker screw, give a little more robustness to the screw itself. Again, all this goes into the design process. There's a lot of intricacies. You just think like, oh, I'm gonna stick a screw in there, but I guess there's people that do those jobs, right? Like you got to find what exactly you want, and you can fall into a deep rabbit hole with this as well. Let me just see. Yeah, so now we're going to assembly, right? Specifically electrical. You have to pick the right wiring for the job. Again, if you look at the gauges, right? If you're expecting high current, high power to go through these wires, then you're gonna pick a thicker gauge, right? If it's like if it's a thin wire that just used for, I don't know, like a light. Sorry, if it's a wire used for just like an LED or a light, then you can go thinner, right? It depends. You choose the right wire for the job. Again, you have to take into account that these weigh something as well, right? Like a meter of wire, weighs a lot. So it's another thing to consider when picking the sizes. Soldering, crimping, all these ways to connect wires to each other, right? Usually, I think we do a lot of crimping, just because it's good for easy switching stuff. Right? Let's say a perp breaks, if you use the crimp to connect the two wires, you can kind of see this one slides in. It's easy to switch them out. It's another focus, right? You have ring connectors as well that you can screw down. So these are all types of things you need to consider. And then you also want to consider the strength of the hold. Like, do you think it's going to slide through impact, or do you think it can survive, right? This is another type of crimp that we use. This one we actually do use. Yeah, where the two pieces slide together, there's a no filament. So yeah, power switches, same thing. I think going back to the picture that you might have seen before of both Annie, I know definitely in the open face of the Beyblade robot, you can kind of see this big round switch, right? You don't want that to turn off in the middle, and you also want to be able to handle the current going through. Layouts is a big one. So here, actually, I can mention this. The layout of the inside, you think it's a puzzle, and then you go and put everything together, and maybe you're like, oh yeah, I can fit these into tight spaces. It's great and all, but you also want to lay it out easy enough that you can stick your hand inside the robot, actually put things together and take things apart. Because if it fits like a really nice, tight puzzle, right, and then you need to take something out, you're screwed if you have to take everything out to get to a specific part. So you want to make sure that you're also designing it for, design for fixing, if anybody's doing praxis out there. Routing, same thing. Do you want the wires routed towards the outside? Do you want the pieces on the outside close to the border of the robot where it's going to get damaged, or do you want it on the inside? That all matters. Are you going to throw it over top of the motors, underneath it, around them? Right. So things that you kind of need to look out for. You might think that you want to stick a wire somewhere, but it's good to know exactly where it's going to go. This helps later when you want to, again, go in there and change something, or so that it doesn't move around. And then that'll harden. Glue, right? You have a motor that is going to stay there the entire time, and you have a solder joint that you created, or a crimp, right? You can always glue it to make sure that it has less of a chance of just disconnecting. It's pretty important as well. Right? You don't want something just randomly disconnecting during fight and stopping to work. Now we have the drive system. So this is how you're going to move the robot. There's a lot of different types. Go through them. Tank treads, they have really good traction, but they turn slowly and they move slowly. Right. Also, it's easy to, turn on the spot, but you can do that with any type of two-wheel system. Yeah, then you have legs. This is pretty much impossible for this task, but again, you've got two heavy legs they need to carry an entire robot. But it's also very difficult to design. So normally, I don't think we ever do that. Two-wheel drive, simple and easy to build. It's hard to control and easy to spin out. 4 or more wheels, right? This is more contact with the ground. Yep, harder for wedges to get under, that's important. And then it's a lot more stable, but it weighs more, it takes up more space, it costs more. You need to use more electronics, right? All this stuff adds up. Omnidirectional drive, if you guys know what that is, it's where the wheels are kind of angled and the wheels on top have like little wheels on top of them so that you can move forward, back, side, side without without having to actually turn. So it allows you to move in a lot of ways without having to turn the robot. This isn't great if your weapon is facing forward, right? Like usually if your opponent is to the left of you, you'd want to turn to the left. But let's say something for the spinner robot, the Beyblade robot, where the entire body is the weapon, this would work, right? Because no matter which way, we're always ready to attack. So one problem with this is bad traction, and the wheels are very fragile. Again, if you've ever seen them, it's very easy to knock off the wheels that are on top of the other wheels. You understand what I'm saying? So these are all things to consider. Two-wheel drive, there's usually a caster as well, just kind of to add stability, which you can see in our designs from past years. Yeah, now we'll go a little more into detail, right? Tank controls, each wheel is powered separately. You can move, if you ever had like a remote control that's tank style, if you push both forward, you go forward, push both back, go back, and then one forward, one back spins, the other one forward, the other back, you spin the other way, which is the allowing to turn in place. And yeah, there's not much coding design or anything like that, because you can just make one wheel turn faster than the other, and you'll steer. So it's pretty simple drag style.
All right, so this is the classic design scheme for the actual wiring of the robot. So as you can see here, it's essentially, for anyone who's worked with RC cars before, it's basically a glorified remote control car. So obviously you have the receiver in the top there, so that's what actually gets the input from the remote control and communicates to the robot what to move and how to move it. You have drive ESCs there. So what those are essentially motor controllers. So they basically take the input from the receiver and take power from the battery. And if the receiver says that it's time for the motor to move, they will then send the requisite power over to the drive motor. You have the battery there, obviously, the switch. So that's like what was mentioned earlier. Part of the rules of the competition is that you do have to have a specific switch wired into your robot in order to be able to shut off all power to it when necessary. And that's just a safety issue. And then finally, we have 2 drive motors you can see, and then 1 weapon motor and 1 weapon ESC. And those are larger, which is usually the case, is you will be sending significantly more power to your weapon motor compared to the drive motors, just because ultimately, you need to be able to move the robot around with the drive motors, but you really want to be able to put a whole bunch of energy out using the weapon motor. So this is sort of the basic overview, and essentially, regardless of whatever design we choose to go with, this is essentially what our wiring is going to look like. It might be slightly different, but this is basically what it will be. So next slide, please. So these are the controls. So like I said before, there's the receiver, which is that little black box there in the bottom right. The transmitter above, so that's what we'll actually be using to control the robot. So it looks like a remote controller for a car, and that's because it is. We're using standard transmitters for these, so I forget if the ones we're using are for cars or planes, but either way, it's a fairly standard type thing that we're using. So one thing to consider is the antennas on the actual receivers. So you can see there's wires coming out of it. If the entire robot is encased in metal, it's basically its own Faraday cage. And so if you have the antennas inside of that, you probably aren't going to get great signal, which can lead to a lot of problems. So this is one consideration, is it's often a good idea to have some of the faces of the robot that might not be susceptible to damage as a plastic or something else, just so that you can get those radio signals out, because otherwise you're going to need to route the wires outside of the actual shell of it, which is a risky move. And finally, a battery elimination circuit. So this is another thing with the wiring. And what this essentially is say your drive motor or your weapon motor draws a ton of current from the battery and pulls the voltage down. If this is allowed to happen, what can happen is your actual receiver will then not have enough voltage to power itself. So it loses connection, and then your robot's dead in the water during the competition. So this circuit, it doesn't really matter that you understand how it works, but essentially we'll be using receivers that have this built into them. And all it does is means that if the voltage drops below a certain level, it cuts off power to everything else, maintaining power for the actual receiver itself so that we don't lose control during the competition. So next slide, please. All right, so this one we can skim over rather quickly, but these are just a few different sort of important things to know. Not all of them are actually that important, but I guess the main one here would be pulse width modulation. So PWM, I'm sure a lot of you have heard this, especially if you're in ECE, but that's the actual protocol that'll be used when our receiver is communicating with the ESCs and stuff like that. So we don't really do too much in depth with that, but that is what we'll be using, so it's important to know. And then solenoids are essentially, if you know what a relay is, it's basically a very, very heavy duty relay. So these will be used if you have a massive current being drawn by your weapon motor. And we've already gone over ESCs. So those are basically just the motor controllers themselves. Next slide. So batteries, they seem pretty standard, but when it comes to combat robotics, they're actually something that quite a lot of consideration has to go into. So starting off with battery types, you have sealed lead acid, nickel cadmium, nickel metal hydride, alkaline, and lithium. So all of these have trade-offs and benefits. Sealed lead acid, for example, is very, very heavy. It's literally, they're filled with lead, but they're quite cheap. So for heavyweight combat, generally they'll use lead acid. For our purposes, since we only have 30 pounds of free weight, we'll be using lithium pretty much exclusively, just because it's very light for the power density. And also you can get incredible current draw from a smaller battery, which is necessary when you're working with the small scale that we'll be at. In terms of pricing, lithium is pretty much the most expensive one, unfortunately, but we do think that it's worth the price trade-offs there. Let's see, what else do we have? I guess, yeah, I think that's pretty much it. The rest of this isn't too terribly critical or important. I guess the only other thing to consider is that there are different numbers of cells in batteries. So for ours, the sort of the naming scheme they use is called S. So for example, you have a 1S is 1 cell, 2S 2 cell, and there are corresponding numbers of voltages per cell. So for our uses, I think we'll generally be using an 8S cell, which is a fairly large one, but we do need all of that power. Next slide. So this is just a brief overview of an actual robot. So this is a heavyweight, so definitely a lot more beefy than what we'll be doing. And yeah, so you can see they're using nickel cadmium batteries in the top there. They have their on-off switch labeled. They have 2 drive motors. You can see where it says 2 Victors. Those are the ESCs, so those are the motor controllers. They have a solenoid there, so that's the incredibly large relay that's actually switching power on and off to the weapon motor. They have their RC receiver. And then finally on theirs, you can see that they have an antenna connector. So in their case, I think that this was a full metal shell. So they need to actually route their antenna because otherwise they won't be able to get signal. Next slide. And I think I will be passing it over to Chahit now.
Yeah, so here are some design tips. Because we're fighting with other robots, we don't want to get destroyed basically. So common practice is to not design, to keep fragile stuff in the center of the robot because, it's protected. And then you don't want, for example, if they have like a hammer mechanism, you don't want them to kind of just destroy it. So if it's in the center, it's well protected. And then we also don't want to design holes too close to the center or near fragile areas, because then that would decrease the strength of material on that side. But making holes is a good way to reduce weight. But we have to be smart enough to like choose where we want to create them. We don't want to decrease strength around fragile stuff. And also we need to design so there's enough hand room to make the connections and fix it, because we can't build like 2 of the same robot. So we need to be able to fix it. So like point 3 and 4 go hand in hand, because we need to replace and kind of fix the robot after every round. Hopefully our robot's strong enough that it doesn't break. That's the aim, but we got to be prepared for if it breaks. So we need to make sure it's easily fixable, but at the same time we're not compromising on its strength. And then next slide, please. Here are some rules for the competition that we usually go for. Robo Brawl, we usually go for the 30 pounds one. That's what the 2 designs that we have are based on. It is a double elimination round. So basically, the plan, it goes out. So you go until you get knocked out. And then here is the rest of it is just very specific to the competition. Here, it's just showing what's allowed and what's not allowed. And you would be considered eliminated if your robot does not move. So yeah, that's about it over here. Next slide, please. And here are some forbidden weapons, which is, I think, what a lot of people are interested in. So yeah, we can't have electrical weapons, radio jammers, noise generators, EM fields, which would be pretty sick in my opinion, but unfortunately it's not allowed. We obviously cannot have materials that can spill. So spill, and also no flamethrowers, no heat, fire, smoke, and obviously no light or something that could impair the vision, or something that could blow up the arena. We got to be mindful of not causing too much damage to the arena itself. Yep, and next slide, please. So, yep, sign up for the team. This is the form. Actually, I don't think so. This is the right one. I'll actually copy paste the new one in the chat. This is a link to the form. This was there on the previous slide as well. Do not scan this barcode and this link. The one that was there in the previous PPT, use that, and I've put in the description as well. Yes, and please sign up for the team. And if you guys have any questions, so feel free to put in the chat or unmute yourself. Is this the same? Yeah, it's the same form in the general kickoff. Yeah.
I had a question.
Yep.
How do you use tethered projectiles if ropes and chains are not allowed?
You can't use. I don't think. Oh, sorry. I don't think you can use. Oh, tethered projectiles are allowed. Oh, here's a good example. So I think Samurai wanted to do this at the beginning, if I'm not mistaken, right? Where they had a spinning wheel with a javelin attached to it. So if you can think, try to imagine that the end of a stick is attached to the wheel at one point, right? So when the wheel moves forward, like when the wheel spins, if it's horizontal, the wheel, yeah, if it spins, it's kind of like a piston, right? So when something spins, the piston goes up and down. Similar design. Yeah, go for it.
Oh, I was just gonna say, yeah, just to clarify, also the entanglement is like loose ropes and chains. It's not that loose ropes and chain, or it's not that ropes and chains are banned entirely. It's that you can't like just have a bunch of rope that you flop onto the arena in order to tangle up someone else's wheels. So you are allowed to use them, just you aren't allowed to use them in that specific case. So for tethered projectiles, like you could have rope or chain to actually tether it to your robot.
Okay, thank you.
Yeah, so how a meeting works. Well, that's what we kind of have to decide now. We can do weekly meetings. I think that's good. It kind of uses it as an update, right? Like you come in, you update on progress, you kind of go through what you've been able to achieve in the last week or whatever. And we need to pick a time for that. So, if anybody has any suggestions on it, I think a good time could be Saturday, kind of in the afternoon, just like what we have. You can do it at 12 p.m. or 1 p.m. What do you guys think? What are other people? What's good time for, I guess, people here? Anyone? Is everybody into? Oh yeah, go for it.
I had a question. Yeah, like with the tethered projectiles, has there ever been a robot that's performed well and had one?
I think that in the case of featherweight, I don't know specific robots, but I think generally speaking, it's challenging. So we were hoping to do that with the samurai robot, but I think ended up deciding, like, given the weight limit, it's just really hard to actually fit it all in there. So I would say I don't particularly think that anyone's ever been successful with it that much. Like, it's usually better to stick to something simple and tried and tested, and then just make sort of variations of your own to it.
Yeah, I think tethered projectiles are very difficult to achieve, especially in our class.
Hi, yes, I just wanted to ask, where would be our primary means of communication?
So we'll have a
Like
Slack
outside
channel.
of meetings?
We'll have a Slack channel. But again, if you guys prefer, we can also do a messenger chat, a messenger group, like a Facebook Messenger. And I guess both of those places are pretty up in the air. Right? Everybody will join the Slack channel, hopefully. And then the messenger is, if you guys want to, we can have one set as well. It's another thing we should fold on quickly. And then we'll add you guys to for meetings. So I was thinking we keep it to the weekend. Right? Then we're not dealing with classes at all. Yeah. Is everybody in Toronto? So that's mostly for the people wanting to join the team. Are you guys in Toronto? Yes. Yes. Okay, good stuff. I'm going to say something. Actually, let's make it easier. Is anybody not in Toronto or the GTA?
I think
And
we
then
can, like,
say
create a
not in Toronto if you are.
Yeah, I think it's better to have like a poll or
Yeah.
something. We could add everyone to the Slack channel and then post the poll there, and then just go from there.
Yeah, that works as well. So we'll add you guys to the Slack channel. So again, we're the entire team, right? So everybody that wants to be here will be on the team. And then when it comes to electrical and mechanical, electrical needs a lot less people than mechanical does. And you'll kind of see that once we design the robot and once we kind of get to that stage, we'll notice that, like, 2/3 or even 3/4 of people are going to be working on mechanical, and maybe some of those people are going to help with electrical, and then the rest of them will be on electrical. Because building takes a lot longer than it feels. You're like, oh yeah, I can build this within a week, and then 3 weeks later, you're like, what's going on, right? So what is Slack? Slack's kind of like Discord. Yeah. Except more professional, right? So if you have a job, you'll either be working on a proprietary software, Microsoft Teams, or Slack. That's usually the 3 options. You can even use a web version, but yeah, it shouldn't be too heavy on the download. Okay, and it's just a good place to activate. Again, just like in Discord, right? There's channels, so it'll be easy to navigate and easy to communicate with everybody. So it's pretty good. And then DMs, Another thing that we want you guys to start thinking about is what type of robot would you prefer, right? So we have the different types of combats. This is going to be another poll, but maybe we can gauge kind of interest right now. I think let's stay away from horizontal spinners. I don't know if my two, if Shahid and Bobby agree.
Yeah.
I mean, I feel like it's up to you guys. Like, horizontal spinners are common because they're easy to do well. So I think, like, even if it's like horizontal spinner, that doesn't mean that they'll be the same. Like, I know you've seen like the 2 that we have right now, they're totally different, even though they're both horizontal spinners. So I think I guess it really depends on what you guys decide you want to do, but I wouldn't necessarily let our designs dictate what yours are or aren't.
Yeah, that's very fair. So again, we can kind of gauge interest in what we want, right? You're totally right. If the horizontal spinner looks like this, it's completely different than anything we've designed. So it's
Also, I believe wedge bots are allowed because the active weapon is the wedge itself.
this
Yeah.
one specifically doesn't, right? You just go under.
Yeah, it doesn't like move. The wedge itself doesn't move up and down to flip things, but the intent of the wedge, yeah, is like driving up to robots and flipping them over. And if they aren't able to work upside down and right side up, some of them are designed to do that, some of them aren't. If they aren't, then the result is that they'll be disabled because they're flipped upside down. So that's how a wedge bot would win. Usually they don't actually do much damage.
Okay, so how does flippy bot work? So this one, I think it's using hydraulics, where this part, you guys can see my mouse, right? This part will go under the robot, and then you use the hydraulics to spring them up. So it'll push them up. That's how the flippy bot works. The drive system is the weapon. Not really kind of separate them. You want to drive the robot, and the weapon has its own motor and system, but you can also combine them. Yeah, I think I should go for it.
Yeah, there was this one message in the chat. How about a bot that can jump on top of other bots and use it weight/blades to crush them? That's like this is a new concept. This is the first time I'm hearing something like that. I feel it's great, but then I feel when you jump, it's gonna be hard to make a mechanism that can, if it's using its weight to crush a board, then that means it will be heavy, and then you don't know how high you would want to jump. It's like, yeah, that was like an interesting concept though. I just wanted to point that out. Yeah.
Also, someone said, do cam-powered shufflers count as non-wheeled robots in this competition? I think I know what you're talking about, and I believe so long as there are no wheels present, so nothing that's rolling, a rolling surface, then yeah, it wouldn't count as a wheeled robot. So yeah, then you would get the double weight. But it's hard to make those reliable, I guess, and fast is why it's such a challenge. But yeah, you could explore that.
Yeah, I think fast is actually a big point for it. I don't think I've ever seen a fast one. So, you don't want to be chasing down your opponent just for them to spin behind you. But it's definitely a very interesting concept. Which I haven't
Yeah.
heard about.
Another one was, could we do a sort of crusher board, a robot? Yeah, I think there are a lot of hammer bots that would just like have a hammer and then just crush. Like you said, you have an idea of a specific one. I think that's Sam. If you want to elaborate on that, or
Yeah, you
we
can
could
also draw it
discuss.
out and give like a very basic mock of it. We can look at it as well. Any ideas are welcome, right? That's kind of the nice thing about this.
Yeah, another thing also we would have to look at is.
Yeah, you're allowed to unmute.
Oh yeah, you can unmute and explain.
Okay, because like what I was thinking was, because I know it has to be lightweight and crushers are usually a little bit heavier, but it could have like almost two longer spikes on the bottom, but one on the top. So when it grabs them, it like folds the bot between the two crushers. If that makes any sense.
I think I see what you're saying. Yeah, so it's interesting. You have to make it strong enough. That's for sure, right? You got to have enough power and enough of a what's it called? Enough space to wedge it in there and then fold it. Another challenge with that is you don't know the style of robot that your opponent is, but it's definitely interesting concept.
I had another idea.
Yep.
about it's like a robot with a projectile plus like something like a battling ram or something. So like if you can use the shoot the projectile to latch onto the other robot and then use it to pull the robot towards it if it has a battling ram. So you can use that to like pull towards the robot and ram into it really hard. Or like something with like a speed boost to like once you're like locked onto the target, just ram into it really hard.
Would that count as an entangling measure?
I think that would count. It's a very good idea. I like it. Yeah, I would count the entanglement. In-person meetings, I definitely want to have them as well. Theo. So
Yeah, same. Like I feel when we have in-person meeting, we could draw and explain much better.
we can ask for your guys' availabilities, right? So we'll have that in the Slack. And we'll also have a question in there for how many people are in Toronto and are able to come. And one thing that we have to figure out on our end, so I'll talk to some of the admins, is if we can get a room or something. And
I think the
pretty much-
My Hall one is closed at the moment. I don't know when that'll be open.
yeah, so there's a little bit of back end that we have to talk to people about to try to figure that out. So that kind of makes it a little more difficult. Just because you don't really want to meet outside where it's not as easy. But if we're able to get a room, then that'll be a lot better. And that's kind of what we're hoping for. Let's see, chainsaw as a weapon. Yeah, I guess a chainsaw is technically legal. It is heavy. A light chainsaw. Yeah, again, it's all good stuff to consider. Things to consider when looking at a chainsaw is how are you going to rip through metal, right? The other person. I'm not saying it's impossible. I'm just saying that's what you want to look at. Right? Horizontal blade, yeah. Again, you guys can unmute if you have something to say. Hearing voices is nice. Rather than talking and hoping that somebody's actually out there.
And also one more thing to consider is we will also have to kind of defend against the enemy's weapon. So like, for example, what if the other enemy has like a wedge board? So we want to make sure, well, our robot doesn't flip, or if it flips, can it flip back? So yeah, we got to think of that as well.
So actually,
Yeah.
let's add on to that. One thing that you might have noticed, if you didn't notice, in our other robots. Let's see if I can hold this up. You guys can still see the screen, right? It changed for you guys.
Yeah, we can see the
Yeah.
first PPT.
So these both had considerations for flipping over. You can see that the wheels go through the entire body of the robot, right? So that means that if it's flipped in both cases, whether it's right side up or upside down, the wheels will still be touching the floor. So you can always continue to attack and continue to defend. So that's another way to design against flipping. Yeah, normally there's no traps, I think. I don't think there's the budget as same as BattleBots. Any more questions, comments? Anybody can, yeah, you can unmute. Are we trying to know if we can invite them to the Slack channel or?
Yeah, I think we can add them. I'm not quite sure. I'll try adding a couple. I'm not sure quite if you could send a link out.
No, everybody that's in here Did you all get my email? Or our email from Utra Light Combat at utra.ca. Should have gone to your school or whatever. Okay, Sam, I don't actually think I recognize your name on the form. So I don't think we have you signed up yet. Oh, yeah, you guys. Okay, so I saw you just filled out the form, so you wouldn't have gotten my first one. That's fine. I'll add you to the email list. Everybody else that did sign up before.
I just sent up, I copy pasted, if you had filled out the form, I just sent out Slack notification. You guys should have gotten it. I sent it out to like 14, 15 people. So yeah, if you guys got it, if you guys just got an email, let me know.
Leo, I don't see your email at all in the form.
Oh yeah, a bunch. Okay, perfect. People are getting it. The Slack.
Did you send it out through email?
What I did is I went into Slack and I clicked on add people and then put everyone's email there from the form.
Thank you. Leo, I copied your email, so I'll have it.
Okay, I can see like a bunch of people joining the Slack channel. I'll add more.
Sounds good. So, Parth, you got the first email, right? The welcome to Utra.
Close.
If you didn't see it, maybe it's in your spam for everybody else. It was sent to your, I think most of you guys used all of you guys used your mail.utoronto.ca, so it might have been like, oh, Light Combat is not a real person or whatever. So check your spam inboxes if you didn't see it, and just so that we can make sure that you get our emails in the future, which will also have a lot more detail about upcoming meetings and things like that.
I just sent to Leo. Okay, perfect. I can see a lot of people join the channel, so that's nice. I would say most of the primary communication will happen there, for the beginning part at least, and then maybe we'll shift. But yeah.
Yeah, we can also have a poll on that, whether you guys want to stay there or move to something else.
And I think there's one more question in the chat about how we're going to share our initial idea. I don't know if we covered that, but I think in the next meeting, we could just have, depending upon how the next meeting is, we could just ask everyone to unmute themselves, put a whiteboard up, and then whoever has an idea, we could just kind of discuss each idea one by one, looking at pros and cons, and how we would do it. Yeah. For the exact time of the meeting, what we'll do is we'll put up a poll on the Slack channel, and then over there, depending upon the available times, if you go ahead with that. There is a comeback channel. No, the channel name is University of Toronto Robotics Association. There'll be inside that there's a channel named Compact. If that makes sense.
We don't have an exact time of the next meeting yet. Again, that will be decided in the Slack. I haven't sent any email with you on the list yet. Sam.
Oh, Sam, could you send your email ID in the
No,
chat?
I have it.
Oh, okay. Okay.
It's yeah, it's on the form. How are you adding people to the Slack channel? There is a combat channel on Slack. Do you see it, Ian? On the left side. Channels. You guys don't have access to the first couple, but it's general random robots and then robo nurse, autonomous directors, and robo soccer and combat manufacturing. Yeah, just fill out the Google form. They'll be on the email list. They'll get added to it. I should say.
Yep. I guess that's about it. If you have any questions, let us know in the chat, or if you're like added to the Slack channel, you could put your questions there as well, or shoot us an email. Yeah.
Yeah, again, last minute questions, you can ask them. If not, then I think we're good for today. Meeting ran pretty well. And we'll call for the next one. Kind of pick the time. Yeah, all right. Thanks, guys. I'll stop the recording.